Let's understand what load balancing and failover are and how they tie in with pfSense. Load balancing is a function used to divide the amount of work that a computer or a network has to do to accomplish a given task. In case of pfSense, you can implement multiple ISP WAN connections, and you can load balance your traffic between these connections. This means that when a device on the internal network makes a request to an external resource, on a per connection basis, pfSense can route the request over each WAN in a round-robin manner. If any gateway on the same tier goes down, it is removed from use and the other gateways on the tier continue to operate normally. Within the context of pfSense, a gateway is a system through which pfSense can reach the internet or another network. Failover is basically the ability of a machine or a computer system to transfer operation from a failed component to an alternative backup component without interrupting operations or process flow. When two gateways are on different tiers, the lower tier gateway is preferred. If a lower tier gateway goes down, it is removed from use and the next highest tier gateway is used. Let's understand these scenarios in more detail from the next use case diagram. This diagram represents a typical pfSense setup to explain failover and load balancing. Let's first look at all of the components involved here. This first cloud represents the internet connection or ISP1. There's also another cloud that serves as a second internet connection or ISP2. So these are basically two different ISPs and each of them connects to two routers, router 1 and router 2. Next, you can see that both routers are connected to the pfSense firewall. This leads to a switch, which then leads to the different endpoints or hosts. So in a nutshell, this diagram has two WAN ports connecting both ISP1 and ISP2 modems or routers to pfSense. It also has a single LAN port connecting to a switch and thereby connecting to the internal LAN network to the pfSense server. First, let's discuss the failover scenario. Let's say you start off routing all the traffic to ISP1. Everything is working perfectly until one fine and dandy day, ISP1 experiences some technical hurdles and it goes down. If you did not have pfSense monitoring ISP1, you would have a few choices to deal with this situation. You could either manually switch over to ISP2 if you have one, or wait for ISP1 to fix their technical problems. Obviously, both of them are less than desirable solutions. This is where pfSense's multi-WAN support comes in. If you configure pfSense to work with multiple WAN connections and implement failover and/or load balancing, then the failover in these extreme cases is transparent to the internal LAN users. In this case, as soon as pfSense detects that ISP1 is down, the traffic will be automatically redirected to ISP2. In this scenario, we can say that a proper failover has been configured. If ISP2 is only used for failover, then pfSense will wait until ISP1 is back up and running. Whenever things return back to normal, pfSense will start routing the traffic through ISP1 again. So this may be considered an active-passive failover. The second scenario is about load balancing across multiple connections, even under non-exceptional cases. Let's say you have two ISP connections, but they're not the same in terms of their bandwidth offering, quality, and consistency of connectivity. ISP1 is a premium provider which offers a bandwidth of 14 megabits per second and a more robust connection. while the ISP2 has a bandwidth of 5 megabits per second. Now, instead of wasting the bandwidth provided by the second ISP, you could configure pfSense to load balance the traffic across both connections and utilize both ISPs to their maximum advantage. Once again, pfSense is extremely flexible about how you implement this load balancing. You could choose to combine the bandwidth from both connections and use both of these ISPs simultaneously, and the load will be distributed among both ISPs. You could also route the traffic across these two ISPs based on certain criteria. For instance, you could configure pfSense to route all HTTP traffic via ISP1, whereas all FTP traffic could be routed to ISP2. A more usual case is that voice and video communication traffic is generally routed via a more robust and bigger ISP, whereas regular email and web traffic is routed via the cheaper alternative ISP. An added advantage of load balancing is that the failover works without any additional configuration. If ISP1 is down, all the traffic will be forwarded to ISP2 and vice versa, so that the entire network does not experience a downtime. This may be considered an active load balancing. Now let's look at the load balancing scenario. In this scenario, consider that ISP1 has a bandwidth of 14 megabits per second, while ISP2 has a bandwidth of 5 megabits per second. Now, if the internet network has a usage of 2 Mbps, it will use both of these ISPs simultaneously, and the load will be distributed among both ISPs based on certain criteria. This scenario demonstrates the conditions required for pfSense to work as a load balancer. And it also shows that it has been configured properly. If ISP1 is down, all the traffic will be forwarded to ISP2 and vice versa, so that the entire network does not experience downtime.